Andy Kettle here once again from Servo Components Systems here in the UK to take you through a setup of a Copley amplifier out of the box, fresh out of the box, into a control panel to get the motor turning and tuned. Before I start though, let me just take you through this control panel, which is sort of a basic setup for a single axis servo system. Here we've got the mains isolation, and then next to that we've got power distribution, the AC going out to the various elements in the panel. Now to the drive itself, we go through a mains filter to cut down EMF, conducted EMF that is on your power lead, so don't go back into the system interfering with other pieces of equipment, and that in turn supplies the main power to the amplifier. This is a Xenus amplifier up here. This panel has also got a DC power supply to not only control the power into the control logics of the drive, but also a motion controller that we've got here, and Ethernet distribution. We've got EtherCAT linking the drive to a controller, and then we have another power supply here, another 24-volt power supply solely for the safety circuit. And on this particular panel we're using Safe Talk Off, which is inherent in the servo drive, and there's more information on that contained within the data sheet. So that's a typical single axis servo system, and then it's all down to configuring the motor, the drive, and of course most importantly the application software, and here we're using a Trio Nano. Okay, so that's the overall control panel. Now let's focus on getting the motor tuning and rotating without the motion controller. So we're going to set it up as we did before, just using the Copley amplifier settings itself. So the first thing we need to do is to put in the motor data, and that you can obtain from either the nameplate on the side of the motor, the data sheet that came with the motor, or in our case our archive. We've taken this motor out of the stores, and there's the data sheet for it, and then we've gone into the motor settings here and entered that data into the Copley environment motor data setup. So first thing we need to do after we've done that is to calculate the amplifier settings for the initial settings to allow us to rotate the motor in a reasonably controlled way. We'll go back and tune it later, but this should get you going. So okay, we can go back to that again, go back there again, and we can save it into Flash, which we actually just did. But also, sorry, one thing I forgot to do is enter the encoder data, which I've already done previously, but that is a 2000 line encoder, which translates to 8,000 motor steps per rev of the motor. Okay, so that's that bit done. Next thing we should do is to tell the drive what sort of system we're going to be tuning and configuring. So it's a brushless motor, it's a rotary, commutation is a sinusoidal, that could be trap, but we've picked sinusoidal. We've got halls selected this time, digital halls, which are 3 switches to help you commutate the motor. We've got a motor feedback, which is primary incremental, as I've just said. We haven't got a load encoder, and we've got a buffer output port, which retransmits the motor encoder if we so wish, but we're not using that. And temporarily I've got it set into position program mode, and we can change the settings if we wish to. Okay, so that's being okay. Next thing we should do is do a auto phase. This time it's going to use the halls to do the phasing, so a slightly different process to the last video, but we still need to rotate the motor in the direction we wish to be clockwise. So I've just done that now, and we get a count on the screen showing us that that's the positive direction. And there, so now I'm going to hit next, which brings up this other window. So that's okay, it's taken the values that it calculated, and we can hit start, and it will Let's just check the motor phase in wiring and the Hall's wiring. So it's come back and said, okay, test complete. That's okay. Now we can go to the next stage, and this is now going to check that you've got the poles and the encoder settings correct. So hit start again, and it'll ask us to observe the motor to make sure it does 1 rev. So if we check that now, it's about there. Okay, it's going to do 1 rev, and hopefully it'll stop back here again. Stop. There we go. Lovely. So did it move 1 rev? Yes, it did. And it confirms the number of poles and the counts per rev. So we go next. And this time it's just going to check the Halls. So here we bring up a pictorial of the Hall states and commanded motor phase angle. So here we go. Start. Okay, so that's passed. And that's it. Finished. Okay, so what we should better do now is go into control panel, and with the seconds calculated, we should better enable it and do a forward, a reverse. Oh, that's interesting. Right, okay. What you didn't see was that it was originally set in EtherCAT mode, and I didn't do a power recycle. So I'm just going to close that. I'm going to save that into Flash. I'm going to do a reset. So I'm going to lose connection for a bit. I've already saved everything, so I don't need to do it again. And it's resetting the drive right now. We're going to come up with a lost connection in a moment. That's interesting, it didn't. Never mind, that's good. So we're going to go into control panel again. Enable. There we go, it's right this time. So what was happening there, it was set in EtherCAT mode, and therefore it was looking at the software commanded direction bit within the EtherCAT interface. So I just got it confused there. So that happens actually when you're switching from this mode into EtherCAT mode. So be sure when you change the settings that you do a compare down and recycle. So there we go. So next one in a moment we'll go and do a check on the tuning. Thanks very much, and I'll see you in a minute. So now we're going to check the tuning, and remember we've not tampered with any gains at all at the moment. We're purely using the settings that the motor calculator worked out for us. So if we just check it, we can go to oscilloscope mode up here and select current. Auto setup is on, then we're going to get commanded current and actual current, and hit start. And here you can see that actually it's tuned it. So it's set it on the side of caution, so it's a bit soft. But nonetheless, as you saw earlier, the motor did turn. So that's what you would get automatically out of the box, if you like. So if I stop that now, close. What we can do is an auto tune. We could do it manually, but let's just go through an auto tune procedure. And here we go. I'm going to hit auto tune down here, and it'll go through all the settings, so from CP0 up to CP 1000 or something like that, and then it'll increment through the CI again, and eventually we will get a optimized current loop. So it takes a bit of a while. Here we go. And you'll actually hear the motor buzzing at this stage, which is quite normal. One thing I should say while we're doing this is that I've got it nicely perched on a tape of a reel of tape. In an ideal world, obviously this would be in the machine or clamped down onto a surface, so that when you do some violent moves, it doesn't actually roll off the table and cause damage. So I'd highly recommend it's clamped down. So don't do what I do, do as I say. So here we go. Now obviously we've got auto tuning current of 1 amp, so what we're looking for is a nice slope, a little bit of an overshoot, a little bit of an undershoot, and flattening off at 1 amp. So we're nearly there now. So it's just backing off the CI now, just to try and find the sweet spot. And now it's just working out the bandwidth. Okay, so I'm going to accept that, close that, close that, and now I'll go back to the scope again and change that, and now just run put 1 amp in there. That's what we tuned it to. Start. There you go. So already you can see it's much better than the calculated values. Now we can go into the gains here and increase the gains a bit, just to bring that up a bit if we want to. Increasing that. There we go. So I'd be relatively happy with that. Stop. Stop. Okay, so click the auto setup, so when I change the function generator to velocity, we change the scope settings. You might want to change these to the values that you're more likely to be using in your application, but I'm going to leave it there and hit start, and this time you'll see the motors moving in a velocity manner. And again, okay, so not quite getting there, so we can play around with the gains here. Double it maybe. Okay, so that's making a lot of vibration there, so that's far too high, as you can see on the scope as well. So that's not what we want, so I've reduced it again. No, so it's set itself off, and okay, right. So now we'll just try and bring it up a little bit, add a bit of VI, integral. You can play around with this for ages, and of course you'd need to do it again when you've fully loaded on your machine. You might want to tweak it. So we're going to leave that there for the moment, and this time finally we're going to go to the velocity loop. Sorry, the position loop. Again, it changes for you, and hit start. There we go. Not bad at all. Just to show you that we're doing 2,666 counts per rev. I've actually changed that to 8,000. Then we should get 1 rev when we do it. Okay, and of course, because I'm going further, if I stop the trace, we may want to extend the period of the trace. So now we should at least get a flat period. Sorry, Gone the wrong way, haven't I? Change that to 1 hertz. That's what I should have done. There we go. So what we're actually looking at here is the commanded position. And in fact, if I stop this and add position, limited position, this then will display the acceleration, commanded acceleration, based on the trajectory limits. Okay, so if I run it, look at it now, we'll see that actually that slope, there we go, follows almost precisely the actual commanded limited position shown in green. So if I stop that now, you can see, look at that, very, very, very close. Okay, so that's that. And next we'll move on just to show you what you might need to do to help you debug, assuming you can't do any of this. So none of this works. What do you do? How can you get some help from the drive? And we'll look at that next. So what sort of things can you do if none of that worked? It's all very well, and I've been there myself. You're showing it all working, it's all lovely-dovey, all works. But then when you do it yourself, you get it out of the box, and it doesn't work. So there are a couple of tools that you can use, and we've shown them briefly. One is the control panel, and the other one would be the manual phase. So if you've got halls, and the halls aren't working, then obviously you're not going to get the motor to rotate. So I can use this panel, and in fact, because I know it works, I can demonstrate it here without getting off my chair. But here you've got the hall states, and we've got W is on and U and V are off. So these will go through a sequence of 6 steps, and only one will change at any time. So if I run it around slowly, you'll see that there we've got U and W on now. And now, if I carry on going, W will go off. Okay, now we've only got U on. If we go a bit further, now we've got U and V on. Then we'll have it so that only V is on. And then we go and we get V and W on. And then we've got W on, so we're back to where we started. So if you don't get that sequence, then you will not get the motor to turn properly, assuming you're using the halls as your commutation. So that's one thing you can do. If we go to the control panel now, we've got active position, and if I zero the counts and look here, you can turn it by hand, but because I've got power, I can make it work. If I do 1 rev, and you'll see the count come up. If I get back to where I was, which is roughly there, you can see we've actually turned 8,000 counts. So if it's a 2,000 line encoder, times 4, 8,000. So if you've entered the wrong value, or the wiring is not correct, then again, you'll have trouble rotating the motor under control. Okay, so what you also get on this screen is your status, and all these have got to turn green at some point. They've all got to be green. Safe talk off, we mentioned this control panel has got safe talk off, and if that's not linked, there's a link you can put on the connector. So if I go over here and hit the E-stop, for example, you'll see it's gone red. If I reset it, this is a PILT safety relay, hit the reset and it's gone green again. So if you can't make that happen, check your safety circuit. Then we've got a hardware enable. Now the hardware enable is not a safe enable. Okay, it's just a digital input effectively, and would not pass any LUV safety standards. But there is an enable on there for normal operation, and that's defined. If I go to inputs here, in the input output setup page. Now, out of the box, input 1 is normally used for the enable, but in fact we can use any input. In fact, you could use 2 inputs. Not that it really improves your safety, but you know, hey, depends on your design and what you're trying to do. So here I've actually got it pulled up. So I've got amplifier enable high, and I've got it pulled up. So I've got no wiring connected to that enable at the moment. So if I pull it down and turn it off, then go back to the page here, you'll see I've got hardware enable. It's not enabled. Okay. So as it stands right now, I'd have to have a wire connected to a source and pulling it up to 24 volts. And input 1 is a 24 volt input. Not all inputs are 24 volt, so be very careful. But input 1 and 2 are, so we're safe to do that. But because I've got nothing wired to it at this stage, I can just pull it up. If I do that now, you'll see it'll enable. The other one is the software enable, and the software enable bit comes from, well, here I can enable it and disable it here, as you can see. But as you saw earlier, I had it configured at one point in EtherCAT mode, and it was also getting its enable from the EtherCAT interface, which is why I couldn't jog it negatively. It always went positive because the direction bit didn't change. Then we've got positive limits and negative limits if they're set. Again, they can be set in hardware. Somewhere here. We passed it. There we go. And you've got the option of hitting the switch and powering down, disabling the drive, or you can click this bit here, which is just off the screen. You can click this bit here and hold the position, so it won't power down. So it'll allow you to drive into the switch and then stop, but it allows you to drive out of it again. So just a few things there to keep an eye on. Obviously motor phase is what we've been through, and if you haven't motor phased it properly, then that won't be active. So just a few pointers there to help you get going. Right, one final thing is we can look at here a number of inputs. We've got looking at current, but of course you need to turn the motor, you need some volts. And this does allow you to monitor the bus voltage. So we're running on 230 volt AC, which relates to a DC voltage of around 320, 325 volts. So again, if there's nothing here, then it's not going to run. Okay, so check your wiring. Okay, so we're going to close that, and I think that's probably it for the moment. Thanks for watching, and we'll see you in the next video.